Good morning, good afternoon, ladies and gentlemen, depending on where you are, and welcome to Solid Edge Clinic number 13. Today we're going to be talking about Solid Edge Eco Designer. Eco Designer is aimed at sustainable design. You probably read a little bit about this in the press or on the blogs around these days. It's becoming somewhat of a hot topic. The Solid Edge Eco Designer product is from a company called TIAC or TIAC, or TRIAC at least, in the US, and they specialize in sustainable design methodologies. This particular product is unique to Solid Edge. It's fully integrated into Solid Edge as an add-on, and as such it's easy to use, and that's because it works on Solid Edge parts and assemblies and the metadata associated with those. So the out-of-the-box property table that comes with Solid Edge, all of those materials have sustainability properties available from the Eco Designer product that match those directly. So you work in your normal environment in part or assembly, and there's a new toolbar that gives you the sustainability aspects. You don't need to be an expert in environmental software. I've been working with it now for a couple of days and on and off, and found it very straightforward. Quite easy to get results that seem to be meaningful or are meaningful to me, and doing comparisons, quite straightforward. It's flexible in as much as you have 5 recognized assessment methods. This is unique to Solid Edge. Most of the products you'll see out in the marketplace have one, and there's not much you can do with them. So it lets you evaluate the indicators that are important to your business or the people who are looking at your sustainability issues. It's extensible, so you can add your own material data, and TRIAC are adding their own, more functionality to the product as they go along. I'll mention that a little bit later as well. And finally, you can collaborate with internal or external sustainability experts. The reports are a good basis to work from. They're very comprehensive. And as I said before, you can leverage your own sustainability data. It's quite straightforward to put back into the system. Okay, as I said, there's 5 assessment methods, and I'll just talk about these in a little bit of detail because it's worth knowing what they're about. The first one, Eco Indicator 99, is a European one, and it focuses on 3 items: human health, which has the unit of daily, which is disability adjusted life years. It's about different disability caused by diseases that may result from some of the materials and processes. There's ecosystem quality, the units of PDFs, potentially disappeared fraction of a plant species, so the effect it's going to have on the plant ecosystem. And then finally it has resources. The units are in millijoules, and it's surplus additional energy that's required to compensate for future use. You can look at this as a single score as well, so that you can do simple comparisons as you change materials and processes. Recipe, again, is a European one, recipe endpoint, and it, again, human health, ecosystem quality, and resources, as it was before. There's just different weightings and different way they measure some of these things. And again, you can generate a single score with this one. Tracy, this is more comprehensive. Tracy 2, it's North American standard, tool for the reduction and assessment of chemical and other environmental impacts. It's set up by the US Environmental Protection Agency, and it's pretty consistent with the way they do things in the US. Now, it has 3 major things it looks at: global warming, acidification, and eutrophication. Now, it also takes into account carcinogenics, non-carcinogenics, respiratory effects, ozone depletion, ecotoxicity, smog, and human toxicity. Quite a comprehensive measuring system, this one. The fourth one, which is the ICC 2007, this is from the International Panel on Climate Change, the IPCC. You've probably heard of them, and this is just about greenhouse warming potential, not warning, sorry. So it's just about climate factors, this one. And then finally, CML2 baseline, a little bit like Tracy. Again, global warming, acidification, and eutrophication is the primary three, and then it also takes in smog, ozone layer depletion, freshwater aquatic ecotoxicity, marine water ecotoxicity, terrestrial ecotoxicity, and photochemical oxidation. And I think that one's that's European as well, so it might be more applicable to what we do. There was a competition run in the States for an eco car recently. It was all designed in Solid Edge, but they used Eco Designer in completing the certification for that car. Quite interesting. Okay, let's take a look at Solid Edge. I moved on a bit far then, and to see how this works for us. I'm going to open a pretty simple assembly, which you've no doubt seen before. It's just a coffee pot. Move it across a little bit. And, okay, how do we start this up? I go to add-ins. Here I've got two add-ins. I've got the Eco Designer and a 3D control for my 3D mouse. So we go to Eco Designer. Gives me a little bit of information about the license I'm running. And you see on the edge bar here it comes up with an icon. I'm going to pin that up so it stays there. Now we just open up that bar a little bit. So here are analysis methods, 5 of them. I'm just going to use it on an eco indicator to begin with. Now here's our materials. Now this is the intelligence that's in here. It's picked up all the parts that are in this assembly, and it's picked up the what do you call the properties that are associated with those parts. This is glass on the coffee pot itself, and you can see it highlighted. And I can go through each one of these. I might change the handle here, and instead of it being polypropylene, what I might do is I might make that out of just out of steel will do. So we just make that out of steel. Might be an odd thing to do, but I'll apply that. So that's now steel in that property list, and you notice it recalculates the part weight and everything. Now the manufacturing that we're going to use on that steel, let's go and mill that. So it's done on a milling machine. Okay. And we can apply, if we go back and look at, say, our coffee pot here, the methods we can have there, it's just tempered glass. If we look at other materials, let's go down into our plastics here, the housing here, it's just polypropylene. And we can have blow molding, etc., etc. It's injection molding and set 2 being there. So for all the different materials, you'll have different manufacturing scenarios that you can use, and their associated ecological effects. Okay, now transportation. Let's be ludicrous and add a lot of air transport to this. So it's maybe it's made in China, flown to Europe, and then shipped. So we'll do, I don't know, shipped back to us, whatever. So and then it's trucked around the country a little bit, and some rail as well. So we've got all these modes of transport. Again, it's measuring the ecological effects of all these modes of transport. Now the use phase, here I'm saying it's got a life of 8 years, and it's going to use 130 kilowatts of electricity each of those years. Let's just turn that off for a moment, because you'll see in a moment what I'm talking about. I'll just set that to 0. End of life, we'll do a little bit of recycling. Okay, we're now ready to do a calculation. So what I'm going to do is I'm just going to do a single score here. So we'll analyze that. And we can see here the single score due to material, transportation, manufacturing. Use phase is not there at all. So if I look at the impact by individual part, the other 2 parts, so we can see here our heater plate has a lot of transport input, huge amount of stuff. Impact 2, the energy use. So if we look at the energy use, transportation is pretty high on all of those, but you know, there's quite a bit in that housing there of material input, and we'll see the effects of making some changes to materials and things later. So what I'm going to do here is I'm going to say, okay, I'm just going to baseline that. So that's my baseline, and when I do some other change or report, we'll see what happens. Before I do any other changes, just let's look at some other ports. So I was talking about Tracy before, so we go to Tracy, and again I can say I want the selected impact. That's the one we're going to get with that. So we do an analyze, and we've got acidification, energy, eutrophication and global warming due to all the components here. Again, you can see again material, transportation, manufacturing, use phase and end of life. Tiny bit of end of life in there, as we can see here in the global warming through recycling. And we look at the impacts of those impacts. There they are. So again, I might baseline that one as well. Okay, let's close those off. Let's go back to our echo indicator. Now, that handle, we made that, where is it, the handle part here. We made that out of steel. Well, I'm going to change that back. The part is, I don't want to change that back to polypropylene, wherever it is. We'll make it high impact polypropylene. I'll apply that. We'll notice, okay, our weight comes down. It'll be injection molded. That's the default manufacturing process, but we could have used, anybody know what fleecing is? I've got to have a think about that. It might be thermoformed, it might be blow molded, calendaring from rigid sheets, extrusion if we're making films and pipes and those sorts of things. But in this case, it's injection molded. So everything else remaining the same. Let's do an analysis, and for some reason it didn't record my baseline. If I look at the other indicator, maybe that will. Tracy 2. I think what I did there was to kill my baseline. Yes, I did. Sorry, the baseline will be on this report. You can only contain a baseline across one report. You'll notice on every indicator, when I change the handle from steel to polypropylene, it's only a fairly small part, that my results improved. So if I look at the, what the part's called, it's called the handle. Handle. It should be in here somewhere. It might be in the next one. There's my handle. If we'd probably looked at that before, we'd have seen that the material input would have been higher. The transportation will be about the same, and the manufacturing input, there's a little bit there because of the injection molding, but that'll be less than the milling. So quite interesting. You can start playing with these factors and see what will happen. Okay, if we baseline that again, so I've set that as the baseline yet again, and I come in and say, well, look, let's rationalize this. We're not going to transport that all the way around the world. We're only going to be shipping it. Let's manufacture it all in, ship it directly from China. So it's maybe 9,000 miles. Internal shipping remains the same. So analyze that again, and notice here that everything came down because the transportation input was less. So if we look at our impacts here, notice the transportation is much shorter. If we look at impact 1, go to our next, and if we analyze our handle here, manufacturing and material are about the same as is transport, so it's built up to a third. If we look at our strap handle here, which is sheet metal, let's just look at how that's produced. That might be interesting. Where is it? Strap handle. So we go into our strap handle here. It's stainless steel. It's turned. Well, it probably isn't turned. It's probably it would be rolled, I would imagine. Have we got rolling in there? RS, powder coating section. Sheet rolling, that'll be the one. So if we do close that window again, we get an idea of it's 0.13 there, and we do an analyze again. Again, we see that's come down, well, it's about the same, but we've got a little bit of input for the manufacturing here. So that's probably a little bit more realistic for what we'd be doing, but a fair amount for the material itself. So it might be worthwhile examining whether we could make that out of some sort of plastic, that handle, and let's try that. So on that handle there, we'd make it out of let's say polypropylene. That'll see if we can get away with that. High impact polypropylene again. Masses come down. Injection molding. It would be might actually be cut from a rigid sheet. Wouldn't be extruded. Might be just cut and wrapped, mightn't it? And glued. Who knows? So we say, I might say just calendaring, and analyze that again. Act 1, the next here, and there's our handle. There's our strap handle. That's come right down. So you can see the effect of doing these things. It's quite marked, isn't it? So our total results, again, we're bringing those all those impacts down. So as we work through this and say, okay, we're getting closer to to what we need, we may want to produce a report. So I'm on Tracy at the moment, so we'll say generate a report. I need to have I need to do an analysis, and then I can create my report. So it's if I can type, it really helps, doesn't it? Put the address in there. It's who's doing it. It's me. To have a title for this, coffee pot, something like that. Email address, phone number, etc. It's an Eco Designer report. We want absolute values in here. We can say OK. And here's our report. It's an HTML file, so pretty straightforward. It gives us all this information as well, and then it gives us this, all the detail parameters of this from this this assembly. So that report you'd send off with the design data to whoever's certifying or whoever needs to have that information. Let's close that down for the moment. I don't want that one yet. Too soon. Getting ahead of myself. So you can see it's pretty easy to use, and it's very flexible, and it makes you think about your individual materials and processes and where things are coming from. So you might say, well, is it better to manufacture it in Australia rather than China or wherever? And really break this thing down. It's quite surprising what you might find out. Okay, back to my slideshow. So you saw that it's easy and quick to use. It sits inside the Solid Edge user interface. It's all familiar, and you can do lots of very simple what-if scenarios. What if we change that? What's going to be the impact of doing this against that? And you can document all of this straightforward. It's very straightforward. Everybody want to know the price. Look, it's about $3,000. But look, call your local Solid Edge business development manager, and he'll be able to fill you in on all the details. And remember, this is just not for greenies. It's not about tree hugging. It's something that I think over time all of us will have to account for one way or another. And it's just use of resources, use of the ecosystem to produce our goods. It's a pretty straightforward thing. Okay, I've had, well, not only myself, but we've had a number of questions about where can we get these clinic replays. I missed one, or I'd like some more detail on it, or he speaks too fast, or the video quality I was getting wasn't the best at the time. Whatever, you can get to them. So where are they? They're on our website, www.edgeplm.com.au. You go to the support tab, online support, login, and then Solid Edge Clinic. So here's our website. When you get on there, click on the support tab across the top here. That will take you to the support page. Right at the top here, click on online support. Having clicked on that, it'll take you to the login page. Put in your username and password that you'd have got from us if you don't have one. Click on this icon here, fill out the form that pops up, and you'll be emailed one. This is for our supported customers. Okay, having put in your login and password, it'll take you to another screen. Scroll down until you find Solid Edge Clinics. Watch the clinics. So let me do it. So here's our website. What do we say? We go to support, online support, log in. And I've got to remember my password. Hope I get it right. Enter. There we go. It's right. There's our online support page. There's a lot of information in here, so have a read through. But here we go. Solid Edge Clinics. And it brings up all the clinics except this one we're looking at right now, which will go up in the next day or so. So there's all the clinics. Now these are from, well, they are in YouTube format. So down the bottom here, you can change your quality. What I do is I set it to auto. And then I go to full screen and you can hear the audio. There we go. You can scroll through. So I'm at 14 minutes. It'll catch up in a moment. You can change your volume level, of course. You can mute it. There we go. So I scrolled through. So pretty straightforward, easy to use. They're all there. I'm going to pause that. It's pause this one, isn't it, that I want to? Okay. You can have them all playing at the same time, actually. That can be interesting. Okay. Questions and answers. There's no questions up on the board, and I've obviously bamboozled everybody, or it is pretty simple. Truly, it's so we've all understood that, and we know where we stand with it. So it just remains to talk about next time. The next clinic, we'll be looking at schematics in the 2D draft environment. Schematics can be electronic schematics, circuit diagrams, electrical diagrams, hydraulic P&ID, anything that has blocks with lines that connect them, logical connections. So they could be logic flow diagrams, all of those sorts of things. So I'll be looking at the creation of those inside the Solid Edge 2D draft environment, and we'll also be looking at our add-on programs that we have from Edge. The first one of these can create a bill of materials from the information inside blocks. So you can add information inside a block, things like maybe a part number, maybe a description, costing, that sort of information. So all this metadata, as it's called, can be accumulated by this program and reported, so we can get a bill of material. So we might have 10 of one sort of block and 5 of another, so we'll have 10 of these valves and 5 couplings and so on. The other program we have does a from to list. So let's take a schematic where we've got a connector with 3 pins on it that goes to some circuit element. So we can say connector 1, pin 4 goes to integrated circuit 3, pin 22, and so on. So you can get a from to wireless. These things can be very useful for automatic routing of printed circuit boards, wiring, doing wiring looms and things for electrical, and process lists for both P&ID and hydraulic schematics. So that'll be a lot of fun. It's next time. And all I can say now is thank you for your time and attention. This video will be up on the website in the next couple of days. Till next time, take care.